Hello everyone, my name is Yao Huang. So today this is our first session about deep learning nano-degree program. And I'm your mentor. So we will cover three topics today. The first one is a brief introduction about myself. I started to learn deep learning, machine learning about 2 years ago. I finished my Udacity deep learning nano degree more than 1 year ago. So I can tell you that this learning journey as a student was really rewarding, but sometimes it was also very frustrating. I still remember when I was trying to finish my last project of reinforcement learning. I was stuck in the middle. But you know, I can also tell you confidently that you are able to do that. So for me, I'm really a very passionate learner. I read a lot of books about machine learning, deep learning. So I'm very confident that I can tell you a lot of theory as well as practices about uh, deep learning models. Okay, so let's get started. The next thing I want to share with you is some fundamentals of uh, of deep learning. So for me, deep learning is a very powerful tool for pattern recognition. When we are talking about face recognition, autonomous vehicle, uh, to play a game like Go or Star Wars, actually the computer is trying to recognize some patterns and to make the decisions based on those patterns. So neural network is powerful and very elegant. Is able to recognize a lot of patterns, even though uh, the cost is it will consume a lot of computation and data. Okay, so let's next. I will give you some brief introduction about the building block of neural network, neuron. In the nano degree course, we have talked about two types of neurons, perceptron and sigmoid neuron. So the commonality between these two types of neurons is uh, they have inputs, maybe one or more inputs, and they have only one output. Between the inputs and the outputs, there are two steps for the computation. Step one, uh, the neuron or perceptron is adding all the inputs multiplied by their weights and bias together. And step two, we apply a function to that sum, and then we can produce the outcome. The difference between the perceptron and the sigmoid neuron is what function we choose. In the perceptron, the function we choose is called the step function, which is just to produce 0 or 1. If the input of the step function is larger than 0, we will produce an output of 1. Otherwise, the output is 0. But this is a very powerful step function because this can help us to make the binary classification. But the problem is it's hard to train. So it's time to introduce the second type of neuron, the sigmoid neuron. The only difference is we replace the step function with a new function called sigmoid. Sigmoid function is continuous and differentiable, and its outcome is between 0 and 1. So it's a perfect option for us here if we want to make a binary classifier. You will also see many other activation functions along the way. For example, the softmax the ReLU, and so on. So just be patient. The next thing in this fundamental part is about the architecture. With the building block of a neuron, we are able to build a neural network. The neural network is normally consists of three types of layers. The first one is called the input layer. The last one is called the output layer. And between the input layer and the output layer, you can have one or more hidden layers. If the number of the hidden layers is larger than one, you can call your model the deep neural network. So it's simple. But this is a very elegant and powerful tool. We are able to modify or change many moving parts of this neural network. We can add more layers. We can change the activation function. And we can also introduce more sophisticated architecture like CNN, RNN. So you will find a very powerful application of neural network from this nanodegree program. Okay, the last thing I want to share with you is about the learning of the neural network, which is not easy. So if we have assigned random numbers to the parameters of a neural network, the neural network is not able to make anything correctly. So we have to train it. Here, the training is called the supervised learning because we labeled all the data. What I mean is, if we have an input, we already know the desired output. If we already know the score and the grades from a student, we know how likely this student will be accepted by a university. Okay, so I will give you three very powerful tools which can help you to do this supervised learning. The first one is called the cost function. Cost function is merely to calculate the error or the difference between the desired outcome and the actual outcome produced by the neural network. Okay, so we have discussed the two types of cost function here. The first one is called the cross entropy. The second one is called the mean squared error. So you can choose different cost functions according to your requirements. But all of those cost functions has one thing in common. They produce positive number, and the whole learning journey is trying to minimize the error produced by the cost function. So because we are using partial derivatives and those mathematical tools, the cost function has to be differentiable and continuous, or we are not able to make meaningful progress in the learning. So the second concept is called the gradient descent. The gradient descent is basically is a iterative process to minimize the error step by step. So in each iteration, we firstly try to modify the parameters of the network, like the width and the bias. After that, the error produced by the cost function will be minimized a little bit. There is a metaphor about this process. We are standing in the top of a mountain, and we are trying to go to the the ground, the valley. So in this process, we are trying to find the steepest direction, and then we make a step in this direction until we finally reach the valley. Okay, the last thing I think this is the most difficult concept. Is called the backpropagation. Backpropagation is used here because usually our neural network is very big. It has many layers, hundreds or thousands of neurons. So we need this backpropagation to assign the gradients to all the parameters. The backpropagation actually is propagating the arrow from the cost function to the outcome layer, and backward to all the hidden layers in the neural network. Okay, so this is all the concepts you need to know about learning. But why is it so hard? I think it's hard because it's very difficult to get the good model. Sometimes the learning is very slow. Sometimes we get the trained model, but this trained model is not able to generalize to new data. So in this course, we are going to introduce a lot of different tools, like the initialization, regularization, and so on. So I hope you will enjoy the learning journey. But the first thing is be patient and enjoy your study. Thank you. Bye bye.